Today let us study about the air standard efficiency of the diesel cycle. As already we discussed about the mean effective pressure and the efficiency of the Otto cycle, and also we have studied about the carbon cycle. Okay, today we will see about the diesel cycle. As I told, the diesel cycle which works already a principle, in this principle only we are doing the diesel cycle efficiency we are determining here. And here also same we have two diagrams we have to consider. One is a PV diagram as well as a phase diagram. This is PV diagram, pressure and volume diagram, and TS is temperature and entropy diagram here. Okay, so here one difference as we studied in the last this Otto cycle, it is diesel cycle is a little bit different as that. Here the heat addition process takes place in the constant pressure process, whereas the heat rejection takes place in the constant volume process. Okay, so that is the process 2 to 3 is called as isobaric process, that is a constant pressure. The heat is added at a constant pressure process, whereas the heat is rejected at the constant volume process, that we can call it as an isobaric process. So same 1 to 2 is a reversible adiabatic compression, 2 to 3 is the constant pressure process. So I can take this as P2 is equals to P3 here. Okay, this is the isobaric process. And next 3 to 4 is again the reversible adiabatic expansion, and 4 to 1 is nothing but we can again take it as an isobaric process as the heat is rejected at a constant volume. Okay, and we have three ratios, very important ratios, that is V1 by V2 is a compression ratio, that we can see V1 to V1 it is compressing compression ratio R, and V4 by V3 is expansion ratio, expansion V to 4 it is expanding, so I take volume V4 is V4 divided by V3 is equal to expansion ratio, that is RE. And last is cutoff ratio. As I told that from 2 to 3 is the heat addition process. That Q1 is the heat is added here in the process 2 to 3. So heat is cutting at the point 3. So we'll take V3 by V2 as a cutoff ratio. Rho. R is compression ratio, R is expansion ratio, and rho is the cutoff ratio. Rho is given by V3 by V2. Okay. So now similarly as we will determine the efficiency. So as we know that efficiency is equals to work done divided by heat supply. Work done divided by heat supply. So as work done divided by heat supply is taken as Q1. Okay. So again as we know that work done can be written as heat supplied minus heat rejected. As heat supplied I will take it as Q1 and heat rejected is taken as Q2. Now substituting the efficiency equation, efficiency is equals to the work done is given by the formula Q1 minus Q2 divided by heat supplied is Q1. Heat supplied is Q1. Now, the Q1 as I told from the PV diagram, the Q1 heat is supplied from the process 2 to 3. So I take as the heat addition is the process 2 to 3. So we know that the heat addition takes place in the constant pressure process. So I will take that as Q1 is equal to mCp. So Q1 is equal to mCp, and the temperature you should take from T3 to T2. That is temperature you can see here 2 to 3. Highest temperature is 3 and 2. So I can take Q1 is equals to mCp T3 minus T2. This is equation number 1. Similarly now I should take for the heat rejection. So heat rejection takes place. Heat rejection in the process. So heat rejection takes place in the process 4 to 1. That is here we can see that it takes place as the isobaric process, the constant volume process. So again I will take here for the heat rejection T4 T4 minus T1. Here the temperature, highest temperature is T4 and the lower temperature is T1. So I take this as T4 minus T1. The process is from 4 to 1. So I can take this as Q2 is equals to M, but this is CPY because the heat addition takes place in a constant pressure process. Here I will take it as CV because the heat rejection takes place at a constant volume process. So MCV, the highest temperature I told that is T4 minus T1. This I take as equation number 2. Now substitute equation 1 and 2 in efficiency equation. So here I can take that efficiency is equals to Q1 minus Q2 divided by Q1. So efficiency is equals to Q1 is given by the formula mCp T3 minus T2 minus Q2 heat rejection is taken by the formula mCv T4 minus T T1 whole divided by, again Q1 is taken by mCp T3 minus T2. Now separate the terms each term. So efficiency is equals to mCp T3 minus T2 whole divided by, again here you get mCp to T3 minus T2 minus mCp T4 minus T1 whole divided by mCp T3 minus T2. Here what happens here, mCp T3 minus T2 get cancels. Again here m by m is cancels. And we have a relation that is Cp by Cv can be written as Cp by Cv can be written as adiabatic index gamma. So that this is taken as adiabatic index. But here we have Cv by Cp. So Cv by Cp can be written as 1 by gamma. Cv by Cp is taken as 1 by gamma. Next. Now I will take this one, this equation. That is efficiency is equals to 1 minus Cv by Cp. Here we have Cv by Cp. So Cv by Cp is taken as 1 by gamma. So 1 by gamma into T4 minus T1 divided by T3 minus T2. This I will take it as equation number 3. This I will take it as equation number 3. First I will take on the equation for the efficiency. Then it supplied I took, then it rejected. Finally I am taking the adiabatic index Cp by Cp is equal to gamma. But here we have Cv by Cp, so I take reverse of that one, that I will make it as 1 by gamma. This is efficiency equation. Now let us move on to the different process. Now I should move on to different process. First I will take the process from 1 to 2. Now from the process 1 to 2. So that 1 to 2, as we told now that the 1 to 2 is nothing but it is a reversible adiabatic compression process. So we should take a PV ratio. This is adiabatic compression process. This is adiabatic compression process. So take the PV ratio, that is T2. Here you can see the T2 by T1 is equals to, so usually that is V1 by V2. T2 by T1 is equal to V1 by V2 to the power of gamma minus 1. This is a very important formula, that is T2 by T1 is equals to V1 by V2 to the power of gamma minus 1. So T2 by T1 is equals to, again as we know that V1 by V2 can be written as a compression ratio R. So I can take this as R to the power of gamma minus 1. T2 by T1 is equals to R to the power of gamma minus 1. So T2 can be written as, what is T2 can be written as, and cross multiplication T2 can be written as T1 into R to the power of gamma minus 1. This is one important equation. I will consider this as equation number 4. That is T2 can be written as T1 into R to the power of gamma minus 1. Now I should take the other ratio. Okay, now I will take the cutoff ratio. Rho is equals to V3 by V2. Now what we should do here is, here multiply and divide by V4. We have to multiply and divide by V4. So here is, so rho is equals to, now multiply this, as we know that this is a cutoff ratio. Cutoff ratio is given by the formula V3 by V2. So now multiply and divide by V4. So here V3 by V4 into V4 by V2. I know this is a very important thing. That is rho is equals to V3 by V2. So V3 by V4 into V4 by V2. I multiply by V4 and divide by V4. So that there will be no any changes here. Now utilization factor. So V3 by V4. You can see here. So V3 by V4 can be written as V4 by V3 can be written as RE. Whereas V3 by V4 can be written as 1 by RE. So I can write this as 1 by RE. And next, what we can write is here is V4 by V2. V4 by V2. We have here V4 by V2. This is V4 by V2. So now from this equation you can see here, this is very important step. Here V4 is equal to V1. Why V4 is equal to V1? Because it is a constant volume process, isoporic process. So I can take here as V4 is equals to V1 because it is a constant volume process. Constant volume process. So now rho is equals to 1 by RE into, in the place of V4 I will take V1 by V2. I will take V1 by V2. So this V1 by V2, as we know that V1 by V2 is given by the formula compression ratio R. So I will take this entire term as R. So rho is equals to R by RE. This is one important relation you should keep in mind. So I will write here, that is rho is equals to R by RE. This 1 by is required for me in the other steps. Okay, now we will go for 2 to 3 process. As we know the T2 value we got, next we will go for the another process, that is 2 to 3 process. So now 2 to 3 process. Now consider process 2 to 3. So process 2 to 3, as we know that it is a constant pressure process. It is a constant pressure process. So I will take PV by T equation. That is P2, because 2 to 3 we are taking P2 divided by P2 is equals to P3 divided by P3. Okay. So P2 V2 divided by P2 is equals to P3 V3 divided by P3. As we know that it is a constant. It is a constant pressure process. So P get cancelled here. P2, P3 will get cancelled. So remaining V2 divided by P2 is equals to V3 divided by P3. Okay. So this is the relation as I done that P2, I cancel the V2 by P2 is equals to V3 by P3. Here what I will do is V2 by V2 is equal to V3 by T3. Now I determine the value of T2 here. Here I should determine the value of T3. Now I take this value here. T3 is equals to cross multiplication. T3 can be written as V3 by V2 into, we will get T2. Now again T3 is equals to, as we know that what is V3 by V2 can be written as cutoff ratio rho. So that here I will take V3 by V2 can be written as cutoff ratio. So I will take this as V3 by rho into V2. This is another equation. I will take it as equation number 5. T3 is equals to rho into V2. Next, here what we should do here is again, as already we know the value of T2 here. Now substitute this T2 in this equation. So we will get T3 can be written as rho into, what is the T2 value here? T1 R to the power of gamma minus 1. This is what I did here is I have taken the T2 value and substituted in the value of T3. So that T3 is equals to rho into T1 R to the power of gamma minus 1. This is the step first I am considering the adiabatic compression process, and here I am considering the process 2 to 3. Now as I consider the adiabatic compression process, next I should go for the expansion process. Now expansion process. So before that I note the value of T2 is equals to T1 R to the power of gamma minus 1. Okay. So now I have completed 1 to 2 adiabatic compression completed, 2 to 3 is a constant pressure process completed. Now 3 to 4. I will take 3 to 4. It is an adiabatic expansion process. So same process, adiabatic expansion also. Here you consider the value of the T-V ratio. Again I take T3 by T4 is equals to, same here we can see 3 to 4 temperature 3 is more, 4 is less, so I take T3 by T4 is equals to V4 divided by V3, correct? V4 divided by V3 to the power of gamma minus 1. So I take this to the power of gamma minus 1, this is the formula. So now T3 by T4 is equals to V4, as I told, for V4 from this process you can take that V4 can be written as V1, correct? V4 can be written as V1 from the PV diagram, and again what is V3? V3 can be written as, so V3, this is the V3 value, so I can take it as V1 divided by V3. V3 is equals to V2. From this process 2 to 3, and this is V4 by V1. So I can take it as V1 by V2 to the power of gamma minus 1. So again this V1 by V2 can be taken as R. So I can take this as R to the power of gamma minus 1. Okay. Otherwise we can do in the other method that V4 by V3. As we know that here directly V4 by V3 can be taken as R. Okay. So now don't take this V1 by V2. Direct formula, as we know that here we have V4 by V3. So V4 by V3 is directly we have the expansion ratio, that is we know that V4 by V3 can be written as expansion ratio RE. So I can take it as RE to the power of gamma minus 1. RE to the power of gamma minus 1. From this relation we know that rho is equals to R by RE. This is the formula we have, that is utilization factor is equals to compression ratio divided by expansion ratio. So I want RE. So RE can be written as R by utilization factor. Now T3 divided by T4 is equals to RE can be written as R divided by rho to the power of gamma minus 1. So T3 by T4 can be is equals to R to the power of gamma minus 1. Now I want to see here, I will rewrite this one. T3 divided by T4 is equals to, first I write this numerator, R to the power of gamma minus 1 divided by rho to the power of gamma minus 1. Here we can check that T3 by T4 is equals to R to the power of gamma minus 1 divided by rho to the power of gamma minus 1. As we determine T3, as we know the T2 in terms of T1, so now easily we can determine the value of T4. If I want T4 cross multiply, T4 comes here, this comes to denominator. So T3 into rho to the power of gamma minus 1 divided by R to the power of gamma minus 1 is equals to T4. Correct? So T4 I am considering, already I know the value of T3. I know the value of T2, I should determine the value of T4. So T4 can, on cross multiplication, T4 will come this side and R to the power of gamma minus 1 come denominator. So T4 can be written as T3 rho to the power of gamma minus 1 divided by R to the power of gamma minus 1. Now substitute the value of T3. Now substitute the value of T3 in T4 equation. So now what will going to happen? T3 we know that rho into T2 into rho into T2. So this one here we have T3 value, this value I can take this one. Rho into T1 R to the power of gamma minus 1 into rho to the power of gamma minus 1 whole divided by R to the power of gamma minus 1 is equals to T4. Okay. So this one. Now listen here. So rho into T1 R to the power of gamma minus 1 into rho to the power of gamma minus 1 divided by R to the power of gamma minus 1. Now what happens here? R to the power of gamma minus 1, R to the power of gamma minus 1 get cancels. Remaining is rho T1 rho to the power of gamma minus 1 is equals to T4. As we know the basic mathematics formula, when the bases are same, powers can be added here. So that we have the base rho is common here. So I can take like this. T1 into rho to the power of gamma minus 1. Here with the basis are same, powers here we have plus 1. So I take plus 1 is equals to T4. Now plus 1 minus 1 get cancels. So I can take T4 is equals to T1 into rho to the power of gamma. This is the equation. Okay. So now what we have done here is we have determined the value of T1, we have determined the value of T2, T3 and T4 in terms of T1. Okay, so now all these three values, that is T2, T3, T4, everything is substituted in the equation number 3, that is the efficiency equation. Now what I will do is, now I know the values of substitute the values of T2, T3 and T4 in equation number 3. Now what you take all the values, whatever the values you have. So now what I will take is, now I know the value of T2 is equals, already derived, T2 is equals to T1 can be written as T1 r to the power of gamma minus 1, Now I take T3. What is the value of T3 as substituted? T3 is equals to T3 value. So I take T1 r to the power of gamma minus 1 into rho. Okay, this is another value. This is the value of T3. Now we know the value of T4. What is the value of T4? T4 can be written as, already I derived. These two equations I already derived. That T2 is equal to T1 r to the power of gamma minus 1. T3 can be written as T1 r to the power of gamma minus 1 into rho. Then next is T4. T4 is T1 rho to the power of gamma. These three values you should substitute in the above formula. Okay. So now what I do, efficiency is equals to 1 minus 1 by gamma. So T4, what is T4 can be written as T1 rho to the power of value of T4 is T1 root gamma. Next again minus T1 whole divided by again T3 can be written as T1 r to the power of gamma minus 1 into rho. This is the value of T3. T2 can be written as T1 r to the power of gamma minus 1. Now what I will do, I will take the common factors here. Here you can see here efficiency is equals to 1 minus 1 by rho. Now I will take here T1 common here. So if I take T1 common, T1 into what is the common factor we have? Rho to the power of gamma minus 1 whole divided by, again you can see here I have the common factor as T1 rho to the power of gamma minus 1 r to the power of gamma minus, again I have T1 r to the power of gamma minus 1 the denominator. Now I take T1 r to the power of gamma minus 1 I will take common into, so I will get here the value as rho minus, here I can take the common, so I will get minus 1. Again here what happens, T1 get cancels, so efficiency is equal to 1 minus 1 by gamma into r to the power of gamma minus 1 rho to the power of gamma minus 1 whole divided by rho minus 1. So this is the efficiency formula which I will get, that is rho divided by 1 by r to the power of gamma minus 1 into rho to the power of gamma minus 1 divided by rho minus 1. I can rearrange this equation again and write in this form also, that is efficiency of diesel cycle. Efficiency of diesel cycle can be written as 1 minus 1 divided by r to the power of gamma minus 1. So in the bracket I can take rho to the power of gamma minus 1 whole divided by this, I think inside the gamma into rho minus 1. This is the final efficiency of the diesel cycle. As I told, again I repeat the same. First you have determined the efficiency equation. The three ratios are very important here. One is the compression ratio and we have a cutoff ratio as well as the expansion ratio. The compression ratio we are taking as R, whereas expansion ratio is taken as RE and cutoff ratio is taken as rho. These three values we are considering, and very important logic is that all the values you keep T2, T3 and T4 in terms of T1. Then easily you can substitute in the efficiency equation. Then you can easily determine that one. Okay. So T2, T3, T4, everything you keep in the same. This one you take one variable. Then T1 you keep it as a common factor here. So T2 is equal to T1 r to the power of gamma minus 1. T3 is equal to T1 r to the power of gamma minus 1. And next here I told that T4, T1 to the power of rho to the power of gamma. All these three equations substitute in the final efficiency equation. And this is the final air standard efficiency of the diesel cycle, 1 minus 1 by r to the power of gamma minus 1 into rho to the power of gamma minus 1 divided by gamma into rho minus 1. This is the final equation or air standard efficiency of the diesel cycle. Thank you.